2 on the self-assessment. So go ahead and just take 10 seconds and look through those learning targets to see what's headed your way in the next week or so. Okay, so now take 3 minutes and work on objective 2 of the pre-assessment. This will give you a gauge about where you're coming into this at. Objective 3 is going to be all new stuff. Objective 2 is stuff that you actually did do in Algebra 1, but that was 2 years ago. So there's a good chance that maybe it's not too fresh in your mind and you might need some reminding. That's what Objective 2 is all about. It's a bunch of reminding. Okay, it's us trying to refresh your memory for what all of this is. So you might do okay with Objective 2 pre-assessment, even though we haven't talked about it yet. Or you might not. So go ahead and do just Objective 2. Try your best. If you get stuck, then start thinking about these 2 questions. All right, if you get stuck or if you finish, start thinking about these 2 questions. So it's 11:45 right now. 3 minutes on your mark, get set, go. So, here are the answers. Check and see how you did. The first 3 all talk about learning target 5. Number 7 talks about learning target 6. And number 8 covers learning targets 7, 8, and 9. All right? So see how you did on those. See if you knew what you were doing, if you had a lot of questions, if you were stuck. If they're parallel lines, then they're the same. If they're perpendicular lines, then their slopes are opposite reciprocals. Because I was given a point and a slope for number 6, I used point slope form. I put my slope right there, and then my y-coordinate and my x-coordinate of my point. Haley?
For number 8, I put for every 10 seconds, light travels 2 miles.
That works. Okay. Yep, every 10 seconds, light travels 2 miles, or sound travels 2 miles. Same thing as every 5 seconds, it travels 1 mile. Same thing. And then write a function down here. Because my slope was 1/5, I put the slope there. This is my dependent variable, so I put it out there. I knew that because it was going up the side. And my independent variable is down here, so I put that times the slope. Now, on your self-assessment, we're just looking at Objective 2 right now in the before activities box, because we haven't had any instruction or activities on this in this class yet. So just give yourself a 1, 2, 3, or 4. How do you feel going into this? This will help you decide how many practice activities you need to do. This will help you decide which practice activities you need to do. You have to do at least 3, but you can do more if you need more. This will help you decide which ones to do. Okay? We're just looking at Objective 2. So right now, talk with the people at your table. We're going to take a look at this warm-up. There are 2 questions. Where can we see slope in our world? And when you think of slope, what do you think of? So right now, talk with the people at your table, not the people at a table next to you. Talk about your table. And talk about these 2 questions. We're not talking about lunch or weekend. These 2 questions. So people at your table, these 2 questions. Make sure you have an opinion, something to share from your table, because in about 1 minute, we're going to be calling on people to share, and you want to make sure you have something good to say. So be a good representative of your table. On your mark, get set, go. Joe, it's not your turn with the card, but I want you to share what you just shared with me, because that's a cool example of slope in our world. So Joe, when did you see slope in your world?
When I had to put my lawnmower on the back of my truck, so I parked my truck in the ditch, so the slope was in this like steep.
Good, good, thank you. Caitlin, where do you see slope slope in your world?
I wanna do it.
What did Autumn say?
No, I didn't. I said hill.
She said hill. So hills. Hills is where we see slope. If we're going uphill, it's a positive slope. If we're going downhill, it's a negative slope, right? Brandon, where do you see slope in the world? Skiing or snowboarding. Yeah, in fact, when you go skiing, what do we call those hills?
Hill.
Slopes, right? We call them slopes.
See, I told you.
Why do we call them slopes?
We're hitting the slope.
Because they have a slope. That's right.
Hill.
Slope is such a weird word. Slope.
Emily, where do you see slope in the world?
On line graphs.
On graphs. Like, yeah, if you see a graph, you can see that the lines have different slopes. Good. Neil, where do you see slope in the world? Where do you see slope in the world?
I said you hill.
Give you something to say.
Graph.
I'll say
Stairs.
You won't say it.
Yeah. Up, over, up, over, up, over. That's how we find a slope, right? Rise over run. Exactly.
Say what?
Oh, you're smart.
In fact,
One go down.
yeah. There's a lot of rules about stairs because you can't have too steep of stairs.
No walls.
Like when we were making stairs to go up to our fire escape from our basement, we had to look and make sure that our stairs were up to code, which meant they could only rise so much for each run.
Why? What's the difference?
That you can't have a stair that's like a foot wide and like 2 feet. So learning target 5 is talking about finding the slope in an equation. In algebra, you learned about 2 different types of linear equations that have the slope in them. One of them we called slope-intercept form, and that was y equals mx plus b. The other one we talked about point-slope form, and that was like y minus the y coordinate equals the slope times x minus the x coordinate. This one probably rings a bell for sure. I don't know if this one doesn't do this quite as much in algebra, but both of those have the slope in them, and the slope is the m. You can remember that because the m stands for mountain, which a lot of you said you thought about with slope is mountains. The m is slope. I don't know why they use m to represent slope in math, but they do. So the slope is m, and it's always the number that's multiplying the x part of the equation. So it's multiplying the x, and it's talking about mountain or slope. All right? So m for multiply, m for mountain, m means slope. It's the number that's multiplying the x. So if we look here in this one, the directions say to identify the slope in each linear function. Here this 3 is multiplying the x. So that's my slope. So right now we're just identifying the slopes. We're looking at an equation and we're thinking, here's my equation. Where is the slope located in that equation?
3.
It's the 3. Here, the slope is the number that's multiplying with the x. Negative 3. Here, the slope is multiplying the x. 1/2 or 0.5.
No.
Over here, what's multiplying the x in this one?
-1.
The negative sign, or -1. Yep, so -1. Here, it's -5 is multiplying the x. And out here, it's like there's an imaginary 1 right there, that's invisible 1 that's multiplying the x. That's learning target 5. It's just knowing that the slope is the number that's multiplying the x. This to 4, how do you feel about learning target 5?
Just like finding the slope.
Yep, just picking it out. Okay? So we're good so far. It's all coming back. It's all coming back to me.
Why do you do FIST at 4? FIST has
Because
5.
your self-assessment has 1, 2, 3, 4.
This group is
Why
5.
doesn't it have 5?
Yeah.
I don't know. It should. Last year I did 5. So, learning target 6 is talking about slopes and tables. Hopefully this will also ring a bell. For learning target 6, is the y-coordinate is the one going up and down, right? And the x is going across, Cody? So if we're looking for slope, we're looking for how much we're going up and how much we're going across. That affects the slope, like the wheelchair ramp. You can't go up a whole bunch and over just a little and have this really steep wheelchair ramp. You have to go up a little and over a lot. So your up is your rise, and your over is your run. So we need to figure out what is our change in rise and our change in run. Now slope is always for rise over run, so it's the change in y on top, and it's the change in x on bottom. That's your rise, and this is your run. Rise over run, and that will give you the slope. So if we have a table, we need to look, what is my change in y, what is my change in x, and then put the change in y over the change in x, and that's our slope. So my change in y here, from 2 to 6, that changes by 4. From 6 to 8 is 2. From 8 to 12 is 4. And from 12 to 14 is 2. So those are my changes in y. Now we find our change in x. Well, from -3 to +3, that's 6, 3, 6, and 3. So our change in y over our change in x would look like this. 4 over 6, 2 over 3, 4 over 6, and 2 over 3. So my slope, does it matter if I write 2 over 3 or 4 over 6? Are those really the same thing? They're equivalent, right? I'm just going to pick 2 over 3 because that's kind of the reduced version of it. But if you write 4 over 6, it's equivalent. I'm not going to mark that wrong. That's a right answer. All right?
Oh yeah, I don't get how you got 2 over 3.
So my change in y was 2, and my change in x was 3, so it's just 2 over 3. I could have said 4 over 6,
Oh, okay.
but that's the same thing, because it reduces. All right? Let's look at this one. What is my change in y? How do I get from 20 to 16?
4. -4.
-4, -4, yeah. So 16 to 12 is -4, -4, -4. So my change in y is going to be a -4. Now what's my change in x? And here it's going up by 1 each time. So my slope
-4.
Over 1.
is going to be -4 over 1, change in y over change in x, or I could just say -4. Alright, one more. 8 to 16, actually try this one on your own. Take 20 seconds. Get the slope of your own on this one. If you want to do it in your head, you can. If you want to do it on paper, you can. However it works for you. And some of you would rather visualize it in your head. The last one is learning target 7, and this is finding the slope in a graph. Now, you could think of this as change in y over change in x, or you could think of it as rise over run. The way that we do it is first we find 2 points on the line that hit at corners. And I also put Velcro spots, because on this graph over here, in all of the corners, there's a little Velcro spot that I painstakingly cut and stuck up here, every single one this summer. So, first of all, I would really appreciate it if nobody ripped them off, because not only are they expensive, I messed up my thumbnail trying to do it. Thank you, Logan. Now, let's say I had this line. So we'll start it here and make it go here.
It's like tape.
Velcro.
It's Velcro.
You just said that?
Okay.
Okay, here's my line. It goes from here to here, and then it would keep going, but I just can't reach.
Oh.
So the way that we find the slope of this line is, I'm good, just imagine it keeps going up, is we find 2 points on that line that hit corners. So any two, you could pick this one and this one. You could pick this one and this one. You could pick this one and this one. You could pick this one and this one if you want. But you just need two spots in the line where it's at nice Velcro corners. Or if you're looking at a paper and there's no Velcro, obviously just like the crosshair spot there. And then count how you get from one point to the other. Your change in Y goes on top, and your change in X goes on bottom. So think change in Y over change in X. Just like with the table, we did change in Y over change in X. So over here, let's say we pick these two. To get from one to the other, we go up 2 over 3, so it is 2 over 3. Okay? What if we have one that looks like this?
Don't get all angry.
What if we have one that looks like that? So we got to find 2 Velcro spots, right? So if we just do this one and this one, let's say. Now we're going down 1 and over 4. So what's our slope now?
-1
-1 over 4. Right. So, or you could think of it as a +1 over a -4 because you're going left 4 if you go from here to here. It's the same thing. Okay? Level. Okay. With the last about 25 minutes, you're going to have an opportunity to decide which practice you would like to do. When you finish that practice, then you can work with for the rest of the hour on the practice activities, which are all over there in the second shelf down. Or you might still want to work from the first shelf because there you need 3 of them that are due by tomorrow for the test that's on Thursday. A lot of you already have them in, but if you don't, then you want to finish those first. Right. I will. Yep. So
Yeah.
here are my questions. Think about you. Think about how you learn. For you, like things that you did in class that you learned a lot from, things that you're like, I don't learn anything from that, but it was fun, maybe. Think about how you learn. If you are somebody who likes to learn independently, like if you just like want to sit there, put your headphones in, zone out, and get it done. If you learn the most by doing that and thinking through things on your own, you're going to want to do the textbook station. If not, if you like to be up and moving and working with people, you're going to want to do the book slope activity with like rulers and books and making slope, or use the wall grid over here with this activity. If you're somebody who learns best by making your own connections, like you like to think through things and figure it out for yourself, you're going to want to do the book slope activity. If you just like being told how to do it and then go from there and just process it that way, then textbook or wall grid. Okay? If you are somebody who learns best when you are up and moving, then the book slope or the wall grid activity. If you like to stay put and just relax and get it done, textbook. Okay? The wall grid people are going to be over here. There are little pieces of paper in here. If you're, wait, hold on, stop. Go back, go back. Glad you're anxious, but head on back. All the way back. All the way back. No, leave the chair here. You sit in your chair. Okay. There are little pieces of paper in here. If you're over here, every single person that's over here has to have a chance to pick a piece of paper out. Either make the yarn go through each of these XY pairs, or some of them have equations on them. And every single person over here needs to graph and write the equation or table and write the slope for every single person. So if there's 6 people over here, everybody's paper should have 6 graphs on it. You need the graph that it makes, write the table or the equation that gave you the graph, and then write the slope. So if there's 8 people over here, everybody's paper should have 8 things textbook problems, so if you like that better. And if you would like to do the book slope activity, that's going to be back here at this table. Use those textbooks and those rulers.